Welcome back to Beyond Statistics. In this video, we're going to talk about the terminal. First, we'll talk about why the terminal is useful, and then we'll talk about what the terminal actually is, and then how to get started with working with it. Let's start with an example where the terminal can be super useful. Let's say that you're a historian researching the life of Mahatma Gandhi through his writing. Gandhi was a revolutionary figure known for his advocacy of satyagraha. This was a philosophy of insistence on truth and political passive resistance that played a powerful role in his campaign for India's independence from British rule. But how did Gandhi first conceptualize this powerful idea, and where did he write about it? To try and answer this question, you will need to sift through many pages of his writings. Gandhi wrote a lot over the course of his lifetime, but how do you effectively search through thousands of pages to find every reference to Satyagraha? Relying on applications to do this can be slow and cumbersome, especially when you're dealing with huge amounts of text. But there's a faster, more powerful tool that's already at your fingertips, one that's been around for decades and yet many people don't know about. This tool is the terminal. With just a few simple commands, you can effectively search millions of lines of text in seconds. Let me show you how it works. In this instance, we can use the command grep satyagraha on the folder with the files in it and instantly find every occurrence of these terms, allowing us to quickly analyze in what context these ideas were used. This is really just the tip of the iceberg. The terminal is not just for search and text, but can be used for navigating your system, managing files, running script, or even interacting with databases. It's an essential skill for data scientists. Let's talk a little bit about what the terminal is exactly. There are two ways to do things on a computer. The first way is the graphical user interface, or the GUI, and this is probably how you're used to interacting with your computer. This allows you to give commands via graphics, with an application and things you can click with your mouse, and things like icons and buttons in Windows. The second way is the command line, or the CLI, which allows you to type text commands into a terminal. You're probably used to doing everything via a GUI. GUIs are easy for beginners because they're very intuitive and easy to use, and they're the default on most PCs. But the command line interface offers a wide range of functionalities and options, is much faster and efficient, and it gives you a tremendous amount of control over the system. It also allows you to automate chains of commands to each other. It does have a learning curve, and it requires you to know the details of specific commands. But once you get the hang of it, the command line really makes you productive and it gives you the ability to do things that would be either tedious or impossible with a GUI. Most advanced users and developers rely on the terminal, and while it might seem intimidating at first, learning the basics of the terminal unlocks a very powerful tool that saves you a lot of time and allows you to do things you can't do otherwise. In fact, terminals are the original way that people spoke to computers. There was no graphical interface, everything had to happen via a text command, even writing a document or putting files into the trash. This was the case up till 1979, which is when the first commercially available computer with a GUI was released. As Wired reports, in 1979, the Xerox Palo Alto Research Center developed the first prototype for a GUI. A young man named Steve Jobs, looking for new ideas to work into future iterations of his Apple computer, traded $1 million in stock options to Xerox for a detailed tour of their facilities and current projects. One of the things that Xerox showed Jobs was the Alto, which sported a GUI and a 3-button mouse. When Jobs saw this prototype, he had an epiphany and set out to bring the GUI to the public. Let's show an example of using the terminal. Let's show an example of doing something you already do using the terminal. You might be used to running your Python or R scripts from a tool like RStudio or another IDE, but in the background, RStudio is running your script with a command. Let's try it ourselves. Let's say we have a Python script called datacleaner.py. Now, of course, we can run it from RStudio or from an IDE like Visual Studio, but we can also run it straight from the terminal, and that gives us power and flexibility that we don't have in the GUIs. The basic way to run a Python script from the terminal is by just the word Python and then the name of the file, so python datacleaner.py. We can also add options called flags. For example, python-v for verbose will print information about the program as it's running. In almost any command, adding the .h flag and pressing enter will tell you how it's used and what commands are available. For example, let's try python.h. Now, where actually is the terminal on your computer? Because the terminal interacts directly with the operating system, it looks different in different OSs. In this video, we'll be looking at the terminal on a Mac, which is very similar to the terminal you'll find on any Linux OS. You'll find it by going to Applications, Utilities, Terminal. Now, if you're on Windows, the commands are completely different. Windows has its own command line interface called Command Prompt, or CMD, and it has a more advanced version of the command prompt called PowerShell. To access these, search for CMD or PowerShell in the Start menu. Now, I must caution Windows users that the commands in Windows are very different from those of Linux, because it's talking to a very different operating system. If you're looking for a more Linux-like terminal on Windows, like the ones we'll be showing in this video, you can use the Windows Subsystem for Linux, or WSL, which allows you to run a full Linux environment directly on Windows. You can install the WSL in PowerShell using the command wsl-install. Now, getting back to the terminal, let's review the structure of a Unix command. A command typically has three parts: the command itself, any options or flags, and then the arguments or the parameters that the command will be operating on. The command is the name of the program or the utilities you want to run. Options or flags, which usually start with a dash, like -L, modify the behavior of the command and give the command instructions on how it should run. Lastly, arguments are the targets of the command, like a file or directory name that the command will work on. For example, find is a command that searches for all files in a given directory. Let's say you're working on a project and you've got a directory full of data files in different formats: CSV, JSON, TXT. You want to quickly find all the CSV files that were modified in the last 30 days that are larger than 1 megabyte, but you also want to exclude any files that contain the word backup in their names, maybe because they're duplicates or backup copies of files. Here's a find command that will do just that. Find dot name *.csv, size +1m, mtime -30. Let's break it down. Find is the name of the command. Dot is Unix parlance for the current directory. So find dot tells the command to look in the current directory for these files. Name *.csv matches any file with a .csv extension. Size.1m finds files that are larger than 1 megabyte, which is a typical size for a real data set. mtime -30 finds only files that were modified in the last 30 days. Exclamation point name *backup* excludes files that have backup in their name. This may look complicated, but the more you use the terminal, the more all of these commands become second nature to you. Where do commands come from? Many basic commands are built into the terminal itself. Those you can use without installing them, and they are called built-ins. Find, for example, the command we just used, is a shell built-in. To get other packages, you use a package manager, which is a tool that automates the process of installing, updating, and managing software packages. On a Mac, you can use Homebrew or Pacman. On Linux, common package managers include apt and yum. For example, let's say we want to install the delightful Kause package. We can see on the package page online that it can be installed with the Homebrew package manager using the command brew install Kause. That's typically how you'll install things with a package manager. Once it installs, the command is now available to us. Let's use a command to make the Kause I love statistics. If you're ever unsure about what a command does or you need more details about how it works, you can look at the man page, short for manual pages, for any command. To do this, simply type man followed by the command name. For example, man find will bring up the manual for the find command and show us all of its options and some examples of how to use it. It's a great way to learn more about how a command works and discover additional flags and features you may not have known about. You can also find the man pages online. Most options, or flags, in commands allow us to use either a short or a long version. For example, ls.l tells the terminal to list the files in a directory in a detailed format. Now, ls-long is the long version of the same flag. Both work the same way. It's good to get comfortable with both versions. Using the long form is clearer, but the short form is quicker. Another one of my favorite websites to use with the terminal is explainshell.com. Using explainshell, we can paste a command line argument broken down and explained. For example, let's paste in the command we just wrote before to find certain files in the directory. Another pretty cool feature of the terminal is saved history. You don't have to retype commands you've already used. You can simply press the up arrow to bring up previous commands. It's like your own personal history. Right there, if you know you've typed part of a command before, hitting the up arrow several times brings it up, saving you from repetitive typing. You can also see the history directly by just typing in history. Another great feature is tab autocomplete. If you start typing a command or a file name and you hit tab, the terminal automatically completes it for you. No more worrying about typos. If there are multiple options, hitting tab twice will show you the options available. Now, let's talk a little bit about directory navigation. You'll spend a lot of time moving around folders, and understanding these basics makes life a lot easier. The cd command stands for change directory and changes the directory you're in. For example, let's use cd documents to take us into the documents directory. To look inside a directory, we use ls, which is short for list. Dot refers to the current directory, so let's use ls dot to view the contents of the documents folder. Want to make a new directory? You can use makedir, which is short for make directory. Makedir our scripts will create us a new directory for our scripts. To move files around, we use move source destination. The move command is also used to rename files. So move script.r into r scripts will move the script.r file into the new r scripts directory. Let's check that it exists with the ls command. Yep, we can see it. You can also write a list of commands and save them as a file and then run them all at once. This is called a shell script. For example, let's say you have a list of commands that you run every day. Instead of typing them every day one by one, you can create a shell script. by simply opening the file, adding your commands, and then running it with bash myscript.sh. If you're getting started with the terminal, you'll probably encounter different shells, which are environments where you enter your commands. The best way to think of a shell is as a dialect between you and the operating system, which are mostly pretty similar to each other, but different shells have different features. The most popular are bash, which is the born again shell, and zsh for Z shell. While these two are often used interchangeably, they do have some difference. But most commands work the same across both, so if you're just getting started, don't stress about picking the best one. It's really mostly about personal preference. There are also lots of fun and cool utilities you can install to make your terminal experience more enjoyable and fun. I encourage you to play around and find ones you like. Just as an example, if you'd like to see a visual representation of your directory structure, use tree. It prints out a tree-like structure of your current directory, and it's super handy when you want to get a sense of where everything is at a glance. Or if you want a good laugh, install the package SL, which stands for Steam Locomotive. It's a joke command meant for people who mistype ls for the list command, and when you type SL instead of ls, you'll see a little steam train chugging across your screen. It's silly, but it's fun. I want to finish by emphasizing that while it might seem intimidating, the terminal is not something to be afraid of. It's a very powerful tool that once you master it, boosts your productivity tremendously. As you keep practicing, you'll gradually discover more tricks and tools that make your life as a data scientist so much easier. Whether it's writing scripts or managing files or customizing your environment, the terminal is there to help you work smarter and more effectively. So open your terminal and start experimenting.